Alright, so you want to know how to balance a chemical reaction. Another way they can ask this is they can say, which of the following obeys the law of conservation? So let's review law of conservation real quick. We've talked about in class law of conservation of mass, matter, and charge. And charge we're not going to address in this video, but we will address it in another video. So let's stick with law of conservation of matter and law of conservation of mass. The first one I'm going to deal with is law of conservation of mass. This means whatever mass I start with on the reactant side, so here's the reactants, and here are the products. Whatever mass I start out with the reactants, mass here has to equal the mass over here. Let's say we start out with 50 grams of reactants, then we better end up with 50 grams of products. This is better known as the crap in, crap out, right? That I talk about in class. Whatever crap we start with, better be the crap that we end with. So let's put this in chemistry terms. Here I have a nice little easy chemical equation, and we're going to assign masses. So if I have 30 grams of hydrogen, that's a lot of hydrogen, and I'm making these numbers up now, 15 grams of oxygen, then how much water will I be able to make? And if you notice, these are all on the left side of the arrow, and so that adds to 45 grams total. That means the water must weigh 45 grams total, because the stuff that we have on the left, the crap on the left, has to equal the crap on the right. And if that is in grams, then grams of the reactants are going to equal grams of the products. All right, the next law of conservation is the law of conservation of matter. When we're looking at the law of conservation of matter, we are going to be looking at the actual atoms that are on the reactant side and the atoms that are on the product side. So I put down a simple equation, and you will see that if we count the number of atoms of nitrogen, you have 2, and if we count the number of atoms of hydrogen, you have 2. That's how many atoms of nitrogen and hydrogen you have on the reactant side. If you look at the product side, you'll notice that you have 1 nitrogen and 3 hydrogens. Well, that's bad news, because the law of conservation of matter says the number of atoms I have on the reactant side has to be the same as the number of atoms I have on the product side. So 2 and 1 don't match, and 2 and 3 don't match. So what we're going to have to do is we're going to have to get those to be the same. And we're going to do that by using coefficients. And coefficients are the numbers that are in front of these formula units. Alright, so I just copied this down again so that we have a clean slate to work with. And this is the method that I use. After I make my tallies being these numbers right here and these numbers right here that are tallying the number of nitrogens and hydrogens on the reactant side and the product side, I start to compare them. I got 2 nitrogens and 1 nitrogen. Those are not equal to each other. So I'm going to work on the side that is lower. In this case, the nitrogen has 1, so that number 1 is lower than the 2. So this is the spot up here where I'm going to place my next number. That number has to be able to be multiplied by the subscript of nitrogen to get to this number that is in my tally list. The numbers down here mean nothing. They are just telling you where you are working. So I am going to work up here. I'll circle it in red, and I'm going to put a number there. What number can I multiply by the subscript of nitrogen to get to 2? And I hope you're yelling at the computer saying, it's 2, it's 2. So there you have to put a 2. Once you put that 2 in, recount or retally what you have on the product side. So I have 2 nitrogens, 2 times the 1, and 2 times 3 gives me 6 hydrogens. Now I'm going to go back and compare my tallies again so I can see where I have to work. 2 and 2 match, 2 and 6 don't. So this 2 is lower than 6. This is where I'm working. So go up and find the hydrogen that you have on the reactant side. And I'm going to place a number right here. Remember, these numbers mean nothing now. So I'm going to place a number there that when multiplied by 2 is going to give me this tally number. So what number goes there? Yep, it's a 3. I'll put a 3 there, and then I'll recount. 2 nitrogens, 6 hydrogens. Okay, let's double check. 2 and 2, 6 and 6. All right. This is now obeying the law of conservation, and they will often ask you, which of the following obeys the law of conservation? What they're asking is, do you have the same number of atoms on the reactant side and the product side? Keep in mind that this number right here, even though you have nothing written there, is a 1. And so therefore, it's 1 mole of nitrogen plus 3 moles of hydrogen yields 2 moles of ammonia. Sometimes they will also ask us to write the sum of the coefficients. Let's write coefficients. Okay? The sum of the coefficients is 1 plus, you see this little plus sign here? Let's see. That plus sign right there. Whoops. 1 plus 3. There's the 3. Plus the 2 that's over here, because I want the sum of all the coefficients, 1 plus 3 plus 2, is going to give me 6. So my coefficient sum is 6. And sometimes they give you that as a multiple choice question. So be aware of those. All right, let's try one more. This one's a little bit more involved in that it has more elements or more atoms that we have to get to obey the law of conservation. Let's make our tally. Now you'll notice that I wrote down a tally, but what I did, and it's a little trick of the trade here, what I did was I kept this polyatomic ion as one whole unit. So you'll see right here and right here, I kept it as if it is one thing. You might want to do that instead of breaking it into S's and O's. It'll make your counting easier. It'll make your balancing a little bit easier, especially when you're balancing by inspection, which is what we're doing now. We're inspecting the equation and making the number of atoms on the reactant side equal to the number of atoms on the product side. All right, let's count. When I count these guys, I have 1 calcium, 1 sulfate, 1 aluminum, 3 chlorines. There's the 3 chlorines. This side has a lot more stuff. We got 1 calcium, we got 3 SO4s. See, the 3 applies to everything in the parentheses that's written right before it. 2 aluminums and 2 chlorines. I'm going to make my way down the list. Calcium and calcium match, so I'm not going to start there. My sulfates do not match, so that's a potential spot for me to start balancing this thing. Aluminums don't match, and chlorines don't match. I definitely do not want to start with the chlorines, and the reason for that is because I have an odd and I have an even. And I'm hoping that when I change the coefficients of other parts of this equation, that will even itself out. If it doesn't, there's a few other tricks that we can apply. All right, let's go with, I'll use a green pen. So let's go with the SO4s. I'm going to start on the side that is lower. So 1 is lower than 3. So this is the side I'm starting on. I can't put a number in the middle of a formula. I have to put a coefficient in the front, knowing full well that that coefficient is going to change the number of calciums and change the number of sulfates. So what number can I put there that when multiplied by the subscript of SO4? Now, don't get confused. This 4 is not the subscript that we're multiplying by, because that SO4, let's get a red pen, this SO4 is acting like a whole unit. So I really only have 1 SO4 in that formula. So what number can I put here? You can't see what I'm pointing to. Right there, that when multiplied by the 1 is going to give me 3. 3. Right, so I'm going to put a 3 there, and then I'm going to recount all of my tallies. So I'm going to get 3 calciums, 3 sulfates, 1 aluminum, 3 chlorines. All right, going down the list. 3 and 1 don't match. 3 and 3 do. 1 and 2 don't match. 3 and 2 don't match. So I can work on the calciums, I can work on the aluminums, and I'm still leaving these chlorines with the hope that they will work themselves out. So 3 and 1. The 1 is smaller, so I find that calcium, which is right there, and I'm going to work right in front of that formula unit. I'm going to pick a number that when multiplied by the subscript of the calcium, which happens to be 1, is going to give me 3. So this number, where my pointer is, multiplied by the subscript of 1, has to give me 3, which is this number in the tally down here. So I hope that you can see that that's a 3. I'm going to recount 3 calciums now. 3 times 2, because there's 2 chlorines, will give me 6 chlorines, 2 aluminums, and 3 sulfates. All right, let's go down the list. 3 and 3, 3 and 3, 1 and 2, 3 and 6. I'm going to work with the aluminums because I still have an odd and an even here, but it's getting closer because 1 and 3 is half of 2 and 6. So let's hope that these guys are connected. So now if we look up here, 1 is lower than 2, so I'm working on this side. I'm going to put a number here that when multiplied by that subscript of 1 is going to give me this tally. And again, you can see that that's going to be a 2. When we put the 2 there, these numbers go away and I recount. So I've got 3 calciums, 3 sulfates, 2 aluminums, and 6 chlorines. 2 times the 1 gave me 2 aluminums, and 2 times the 3 gave me 6 chlorines. Well, 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 look at that. 3 and 3, 3 and 3, 2 and 2, 6 and 6. Give yourself a gold star. Yay, we did it. Okay, now, what's the sum of the coefficients? The coefficients are always the numbers that are in front. So that's this number, this number, this number, and this number. What is this number? Right, it's a 1. If there's nothing written there, it's a 1. Let's write it in black so you can actually see it. So the sum of the coefficients is 3 plus 2 plus 1 plus 3. So 3 plus 2 is 5, 6, 7, 8, 9 is my sum of my coefficients. And so if they ask you for the sum of the coefficients, the answer is 9. They can also ask you things like, what is the coefficient in front of the calcium chloride? Well, now they're asking, can you identify calcium chloride, which is right here, and what is the coefficient in front? That would be 3. So read carefully what the question is asking you. All right, I picked this one on purpose because I want to show you a little trick that you can use if you run into a problem where everything is tallying correctly except for one element, and that one element is an odd and an even number. So let me show you what I mean by that by making your tally sheet. Okay, so here I made a tally, and I counted 1 carbon, 2 hydrogens, and 2 oxygens, and then 1 carbon, 2 hydrogens, and 3 oxygens. So here we have a problem because we have 1 and 1, we have 2 and 2, so we cannot work on those. We have to work on the oxygens. And this is the oxygen we have to work on because it is the lower one. So we're going to put a number here. I need a number that I can place here that when multiplied by 2 gives me 3. Now there's 2 ways to tackle this, but I'm going to show you one simple little trick. If I take a number and put it there, that when multiplied by 2 gives me 3, that number is not a whole number. It is a half, right? 1.5. That 1.5 can't stay like that. We can't leave coefficients as 1.5. So let me just resum everything. When I put that 1.5 in there, I get 1 carbon, 2 hydrogens, 3 oxygens. So technically, this thing is obeying the law of conservation right now. You've got 1 carbon, 2 hydrogens, and 3 oxygens on each side. But the New York State Regents always ask for the lowest whole number coefficients. And this right here, my friends, is not a whole number. So we have to get rid of that. The way that we can get rid of that half is by doubling every single coefficient in the equation. So instead of 1.5, when we double 1.5, it's going to become a 3. If we double 1.5, we have to also double these coefficients, which are 1. And 1 doubled is going to be a 2. So these become 2. So my lowest whole number coefficient ratio is going to be 2, 3, 2, 2. All right, so that wraps up the balancing chemical reactions portion. I hope these little tips and tricks help you. You can also watch the worksheet video where I go through multiple types of chemical reactions that need to be balanced.